Hello everyone, welcome to new class. Today's class is the continuation of basic electrical engineering. Let us study about electrical machines. An electrical machine is an electromechanical energy conversion device. So, electrical machine is an electromechanical energy conversion device, and the device which converts electrical energy into mechanical energy is called motor, and the device which converts mechanical energy into electrical energy is called generator. So, motor is the device which converts electrical energy into mechanical energy, and generator is the device which converts mechanical energy into electrical energy. And the electrical machines are classified as, electrical machines are classified as DC or direct current machines, DC machine or direct current machine, and AC machine. AC means alternating current machines. Alternating current machines. And the DC machines are again classified as DC generator and DC motor. DC generator and DC motor. And AC machines are again classified as transformers, then induction machines, then synchronous machines, then fractional kilowatt machines. Fractional kilowatt machines. So these are the classifications of electrical machines. So mainly the electrical machines are classified into two, DC machine and AC machine. So let us study about DC generator. So DC generator. And a DC machine works as a DC generator when it is driven by a prime mover. The principle of operation of DC generator is electromagnetic induction, that is Faraday's laws of electromagnetic induction. Faraday's laws of electromagnetic induction, and it states that whenever a conductor cuts magnetic flux, dynamically induced EMF is produced in it. So whenever a conductor cuts the magnetic flux, dynamically induced EMF is produced in it, and this is Faraday's laws of electromagnetic induction. And the direction of induced EMF is given by Fleming's right hand rule. Fleming's right hand rule. So Fleming's right hand rule is stretch out the right hand with the first finger, then middle finger, and the thumb mutually perpendicular to each other, that is 90 degree each other. Then if the first finger points in the direction of the flux, first finger or the forefinger, so F for flux, then if the forefinger points in the direction of the flux and thumb in the direction of motion of the conductor, then the middle finger will point in the direction of the induced EMF, and this is Fleming's right hand rule. The essential components of a generator are magnetic field, then conductor or group of conductors, then motion of the conductors with respect to the magnetic field. Constructional features. A DC machine has two parts, the field or stator and armature or the rotor. The stator is the stationary member and consists of the field system. The rotor of the DC machine houses the armature winding. So this is the simplified cross-sectional view of a DC machine. The field magnet consists of pole core, then pole shoes and yoke. So field magnet means, and also the magnetizing coil. So field magnet means pole core. So this is the pole core, then pole shoe. This is pole shoe, then yoke. So this is yoke and the magnetizing coil. So there will be magnetizing coil in the poles. The pole cores are usually made of number of steel sheets stacked and riveted together. And the pole shoes serve two purposes. They spread out the flux in the air gap and reduce the reluctance of the magnetic path, and also they support the field coils. The field coils or pole coils are made of copper wire or strip, and these coils are wound to the correct dimensions. And the field poles, when excited by DC current, produces magnetic field. Then armature core and windings. So armature core and this is armature winding. The armature is a laminated cylinder. Armature is a laminated cylinder and is mounted on a shaft. The air gap between the armature and field poles is kept very small to minimize the reluctance of magnetic circuit. The laminations reduce eddy current loss in the core. Armature windings. So these are armature windings. Armature windings are housed in the slots which are on the periphery of laminated armature. Then commutator and brushes. Commutation is the process of conversion of the AC current induced in the armature to DC at the output circuit. The commutator and brush arrangement is the connecting link between the armature winding and the external circuit. The commutator is of cylindrical shape and is made up of wedge-shaped hard-drawn copper segments. Then the brushes are usually made of high-grade carbon because carbon is a conducting material and also provides lubricating effect on the commutating surface. Bearings and shaft are also present in the DC machine. Armature winding. Coils of the armature windings are made from insulated copper conductors. And generally, there are two types of armature windings, lap winding and wave winding. Then, lap winding. Armature coils are connected in series through the commutator segments in such a way that the armature winding is divided into as many parallel paths as the number of poles of the machine. So here the number of parallel paths is equal to the number of poles. So in lap winding, the number of parallel paths equal to number of poles. Then in wave winding, armature coils are connected in series through the commutator segments in such a way that the armature winding is divided into two parallel paths irrespective of the number of poles of the machine. So here number of parallel paths equal to 2 always. So that is about the constructional details of a DC machine. So thank you for watching the class. If you like the classes, please like, share and subscribe my channel.